So this is the third part of linear block code. Here we are going to understand how to do the decoding problems in case of linear block code. So the problems may appear like this. The generator matrix for 7,4 block code is shown below. So this is the generator matrix. So it is in the form IK, that is identity matrix, appended by or followed by parity matrix. So this is the identity matrix of dimension k. K is 4. So it is 4 by 4 identity matrix. After that there is this one is your parity block. Okay, so this is your parity block, this is your identity matrix. So it is in systematic form. It has 4 rows and 7 columns. Okay, so the next part is received code word is this one. Then you have to check for error and correct if any. So the mostly linear block code, the number of errors to be corrected would be maximum 1 in the as per the exam point of view. Okay, so let us see the solution for this. They have to give you the generator matrix. So in this problem they have given you the generator matrix. So the next part is you have to obtain the parity check matrix from this generator matrix. So you have to remember this form. Generator matrix has the form IKP k into n, and parity check matrix, not parity block. This is parity block, this is parity check matrix. So it has the form PT, that means transpose of this this parity block, and it is followed by IN minus k, identity matrix of dimension n minus k. So H is PT. So your P is this one, 1011 111 0011. So 1011 you have to take it as first row, then 1110 second row, 0111 as third row. So 1011 1110 0111. After that you have to form here the identity matrix of dimension n minus k. N is 7, and k is 4. So it is 7 minus 4 is 3. So here the identity matrix is of dimension 3. So in this way you can form the parity check matrix. After that you have to take the transpose of this parity check matrix. So transpose is, this is column, so make it as row. So 110, second column 011, so second row 011, 111 111 101. So you know the how to take the transpose. So this is HT. So the first step is you have to obtain the HT in case of decoding. After that the received code word is this one, 0101 0101. So this is received a code word. So you have to obtain first syndrome. So syndrome is received a code word multiplied by HT. So this is your received code word, and the HT you have just now obtained. Now this multiplication you have to do. You can go by your traditional method of matrix multiplication. That means this row, this column, all the bits are multiplied, then XOR is done, and you will get 1 bit. After that this row, second column, you will get 1 bit. You have to multiply 0 into 1, then 1 into 1, plus 0 into 1, plus 1 into 0, likewise. Then you will get the second bit. After that you have to multiply this row and this column, like 0 into 0 plus 1 into 1 plus 0 into 1, plus means XOR or mod 2 operation. So that is the traditional method, but it will take very too much time. So the clue is that you have to see here where are the ones. So one this bit corresponds to first row, second bit corresponds to second row of HT. This R is required only to identify the rows in HT. So one is at the second bit position from this side, second. we are considering this as a first position. So this is second, so second row. Then you have to consider fourth row, then fifth is not there, sixth row and seventh row of HT. Okay, so these ones are used to label the rows of HT. After that there is no role of this R. Then you have to add these HT rows. So here I have added that 0 1 1, then 1 0 1, 0 1 0 and 0 0 1. So again addition, for this this is motto addition. Again here you have to use the one rule that suppose you have to do this addition, so you have to count how many ones are there. There are 3 ones, which is odd. So odd ones are there, write 1 as the addition, because you know that in XOR 1 plus 0 is 1, 0 plus 1 is 1 and 1 plus 1 is 0. So whenever odd ones are there, the addition is 1. That's why. So here even ones are there, so 0. Odd one is there, so 1. So addition is 1 0 1. So this method will save your time in the exam. So syndrome is 101. So you got the syndrome 101. So after that you have to see there is 101 in HT. So 101 is first row, second row, third row, fourth row. Fourth, na? Yes, fourth row. That means from this side, fourth bit. So fourth row you have identified. So you have to go in R from this side. You have to see first, second, third, fourth. So this bit is in error. So this bit is in error of R. So how to correct the error? You have to make 1 to 0, because that only you can do, na? There are only 1 and 0 in binary. So the correction will be, so this is in error, so make it as 0. So this is the procedure. So let's take another example for the practice. So this is they have given the generator matrix. This is 6 comma 3. So IK 3 by 3 identity matrix. So this is the parity block. This is the identity block of dimension 3 by 3. This is parity block. Now you know how to do. You have to you have to remember this IKP k into n. H is PTI n minus k into n. So you can see here k. So k into n. N is fixed. Here also. Here n minus k. So rows are n minus k. Now so H you have to form. H is 101. So 101. Then 011, 011, 110, 110. After that identity matrix of dimension 6 minus 3. 6 minus 3. That is equal to 3. So identity of dimension 3. After that you have to form the HT. HT is 101, 101. 011 column, make it as row 011, 110, 110. You know how to form the HT. After that received code word is there. So this is your received code word. So you have to multiply this with this HT to get the syndrome. Now you have to identify the rows of HT as per the ones in R. So 1 in R is at third, fourth and fifth. So you have to consider first, second, third row, fourth row, fifth row. Third, fourth, fifth row of the HT, and you have to take those rows. So 110, 100, 010, and you have to do the addition 0. So even 1 0, so even 1 0. So syndrome is 0. So that means R is there is no error in R. R is a correct code word, that is C. Correct code word is indicated by C. So this is second example for the practice. Okay. So let us take the third also. Yes, no? Yeah. Third example. So this is again 6 comma 3 IKP. Then received the code word is there. You have to form H. H is 111, 111, 110, 110, 101, 101. Then I of dimension n minus k, that is 3 by 3. So PTI n minus k. Then form the HT. HT you know how to form. After that syndrome is formed by multiplying R, this R with HT. so r with ht, so that is equal to the ones of r are used to label the rows of ht. So first bit position, so first row, third bit position, so third row, and fourth bit position 1 is there, so fourth row of the ht. After that you have to take those rows of ht, so triple one, then 101 and 100, and you have to do the addition. 1 1, even 1, so 0, odd 1 1, odd 1 1, so 110 is your syndrome. So where is 110 in ht? It is at second row, so that means second bit from this side is in error, so 0 is there, so make it as 1 to correct it. So that is 10, so here 0 is in error, so make it as 1. So this is third example for the practice. So in this example they have given you the parity coefficient matrix. So that is not a parity check matrix, you have to see it is coefficient matrix P. That means it is the matrix here, this matrix they have given, that is parity matrix or parity coefficient matrix. So they have given you P. So how to so if they have given you P, don't go for generator matrix, directly find the H matrix. H matrix is pt I n minus k. So pt is 0 1 1, 0 1 1, then 101, so 101, 110, so 110. After that pt, h is pt and I n minus k. I is n minus k, that means 6 minus 3, so identity matrix of dimension 3 by 3. After that ht, so 0 1 1, 0 1 1, 101, 110, so 100, 010, 010, 001. So ht is transpose of h. After that they have given you the received code word. Received code word is 00110, so 00110, so 00110, and this is your ht, this one. So here r you have to use to see the where are the ones. Ones are at position from this side, 1 is there. From msb you have to msb bit is a bit 1 we are considering, so bit 1, bit 2 are 0. At bit 3, 4 and 5 there are ones, that means 3 4 5 rows of ht you have to consider, 3 4 5. So you have labeled those rows of ht, then you have to add those rows. If you add here 0, so 0, even 1 0, even 1 0, so syndrome is 0, so y is a correct code word, or y or r. They have given it as a y, as a received code word, so we are labeling it as y. So y is a correct code word. So suppose they have given you another example where y is 111, 0 so in this case you have to do the addition of first row, second row, third row, fifth and sixth row, because only at fourth there is 0, so you have to consider the all the rows of ht, and except that fourth row, that means this one. So if you don't consider this one, and you have to do the addition of all the rows. So for example here if you don't